Hello guys, today our PPT is on convolution and correlation of discrete time signals. So we should start from what is convolution. Convolution is a mathematical way of combining two signals to form a third signal. Uh, it is equivalent to finite impulse response filtering (FIR). It is important in digital signals processing because convolution two sequences in time domain is equivalent to multiplying the sequence in frequency domain. It relates input, output, and impulse response of an LTI system. We can see the equation yt is equals to xt into ht, where yt is the output, xt is the input, and ht is the impulse response of LTI. And this is the convolution operation. We should move. What are the properties of convolution? It is commutative, associative, and distributive. Shifting property is also there. So commutative property is nothing new, just we can op- operate that convolution in both the ways, xn hn hn xn. Associative, it is again the simple one, and distributive is also the property of convolution. Shifting property, we can see here, if x hn is equals to yn, then x n minus k is a constant, and here h n minus m is also constant, then y n minus k minus m will be the final impulse. Convolution with an impulse xn del n is equals to a xn, so there is no change when convolution is done with an impulse. So there is a discrete convolution for linear time variant system. If the input sequence xn and the impulse response hn are given, the output sequence yn can be found. This is known as the convolution sum, and it is represented as the given equation, which is kind of similar to the convolution operation. Here there is an input xn, and again LTI process, it gives the output yn with a convolution process. There are several examples. We can see one example of discrete linear convolution. To calculate discrete linear convolution, convolute two sequences, convoluted output will be there. So this is a very simple method. We just have to convolute to any of two sequences. Either it can be EA, BE, CE, and there will be 9 outputs of 3 inputs ABC with 3 inputs EFG. And if any two sequence have m n number of example, then respectively the resulting convoluted sequence will have m plus n minus 1 samples. So it is just basic thing. Examples of discrete linear convolution, again we can see convolute two sequences and convoluted output we will be having this. So there are m and n's, and three inputs, 1 2 3, minus 1 2 2 3, minus 1 2 2. So m is equal to 3, n is equals to 3, and minus 1 that was in the formula, so we can get 5 convoluted output. Here you can see yn, which is equals to minus 1 0 3 10 6, and that is the example. Now we can move on. Periodic convolution. Periodic convolution is valid for discrete Fourier transform. To calculate periodic convolution, all the samples must be real. Periodic or circular convolution is also called as fast convolution. If two sequences of length m and respectively are convoluted using circular convolution, then resulting sequence having max m n samples. So this is the periodic convolution. Let's see. Now we can move on correlation. Uh, Correlation, it is a measure of similarity between signals, and it is found using a process similar to convolution. So correlation is used to compare two signals. It is used in a radar sonar system to find the location of a target by comparing the transmitted and reflected signals. Other applications of correlation are in image processing control, engineering, etc. The correlation is two types: cross correlation, autocorrelation. Let's see cross correlation. Cross correlation, the correlation between a pair of sequence x and yn is given by this equation: r x y n is equals to summation of x of k y minus n minus k, from k minus infinity to infinity, and which will result into xn convolution processes y minus n. Observing the above equation for Rxy, we can conclude that the correlation of two sequences is essentially the convolution of two sequence in which one of the sequence has been reversed. So y of n is reversed by y of minus n, and this is what the cross correlation. We can see example of cross correlation. Here is the example of cross correlations, and in this image you can see y of minus n xn have different values: 1 2 3 1 2 3 1 4, and from this we can compute the cross correlation, and which will be given by Rn. So Rn we can conclude like 2 3 plus 4 1 plus 6, just cross connected and add them only. So we have that xn yn and Rx of xyn can be computed. Let's move on. Correlation. The autocorrelation of sequence is correlation of a sequence with itself. It gives a measure of similarity between a sequence and its shifted version. The autocorrelation of sequence xn is defined as Rxx, and is equals to summation of x of k minus n. It was very similar to cross correlation, but here both the output and input are x and x, k minus n, in which k varies from minus infinity to infinity. Examples of autocorrelation are also here. So find the autocorrelation of finite length sequence xn, and here are the uh, signals that 2 3 1 4 for x of n, and for x of minus n 4 1 3 2, and from this here we can find Rn, which is, you can see Rn is equal to 8 12 plus 2, and further it goes till 13 14 8. From this image we can see in our left side xn, and in the upper side there is a x of minus n, and we can conclude autocorrelation from this relation. Thank you.